Welcome to Senior High School Math Series. Let us have mean, variance, and standard deviation of discrete probability distribution under Statistics and Probability Quarter 3, Week 3, based on Curriculum Implementation and Learning Management Matrix for K-12's most essential learning competencies. Here are our learning competencies. Illustrate the mean, variance, and standard deviation of a discrete random variable. Calculate the mean, variance, and standard deviation of a discrete random variable. Interpret the mean, variance, and standard deviation of discrete random variable. Solve problems involving mean, variance, and standard deviation of probability distributions. Before we continue, let us have this from Joseph Butler, an Anglican churchman and theologian. But to us, probability is the very guide of life. Let us introduce the lesson in Ponder on this. In junior high school, you learn that the mean for a sample or population is computed by adding the values and dividing by the number of values as shown in the following formula. Sample mean is equal to summation of x over n, or the sample, or population mean is equal to summation of x over n, or population. But how would you compute for the mean of the number of boys in a family with 3 children as given in our previous examples? You could try investigating in your neighborhood, say interview 10 families with 3 children, recording the data and finding the mean. However, the answer that you would get only approximates the true mean. What about 30 families, 50 families, or 100 families? It is true that the more families you get, the better the approximation. Then you might ask, how many sample families must you interview in order to get the exact answer? Since this task is not possible, the formula for sample mean or population mean cannot be used because the denominators would be infinite. Before the mean of probability distribution is discussed, consider the following for further understanding of the concept. Suppose 2 1-peso coins are tossed repeatedly and the number of heads that occurred is recorded. The sample space would be the set with elements head, 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 tail, tail, head, tail, tail. Now, what will be the mean of the number of heads? From the sample space, you know that each outcome has a probability of 1/4. And in doing the tossing of the coins many times, you would expect 2 heads to occur 1/4 of the time, 1 head to occur 1/2 of the time, and no head to occur approximately 1/4 of the time. And therefore, on the average, you would expect the number of heads to be 1/4 times 2 plus 1/2 times 1 plus 1/4 times 0 is equal to 1. That is, if it were possible to toss the coins infinite number of times. The average or mean of the number of heads would be equal to 1. The mean of random variable with discrete probability distribution, therefore, describes the measure of the so-called long run or theoretical average of the distribution. To find the mean for a probability distribution, multiply each possible outcome by its corresponding probability and then get the total of the products. Hence, the formula for the mean of random variable with a discrete probability distribution is given by mu is equal to x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 plus x sub 3 times p of x sub 3 until x sub n times p of x sub n. Or simply, mu is equal to summation of the product x times p of x. Let us have an example. In a household with 4 members, find the mean of the number of members who are females. The probability distribution is as follows, as what we have discussed in the constructing of the probability distribution for a random variable. Our random variable here is x, which is the number of females in a household of 4 members, and the corresponding probabilities are if x equals 0, 1 over 16. If x equals 1, 4 over 16. If x equals 2, 6 over 16. If x equals 3, 4 over 16. And if x equals 4, 1 over 16. Hence, the mean is equal to 0 times the corresponding probability, 1 over 16, plus 1 times 4 over 16, plus 2 times 6 over 16, plus 3 times 4 over 16, plus 4 times 1 over 16. Then we have 0 times 1 over 16 is 0. 1 times 4 is 4, so we have 4 over 16. 2 times 6 is 12, so we have 12 over 16. 3 times 4, also 12, so that is 12 over 16. And 4 times 1 is 4 over 16. Now we can add the fractions. 4 plus 12 plus 12 plus 4 is equal to 32. So the mean is 32 over 16, simplified as 2. So that means if you get to interview households with 4 members, in the long run or theoretically, the average of the number of members who are females will be equal to 2. For a probability distribution, the mean of the random variable describes the measure of the so-called long run or theoretical average, but it does not tell anything about the spread of the distribution. Recall that in earlier study of statistics, we learned that in order to measure this spread or variability, statisticians use the variance and standard deviation. But the formulas that we used to know cannot be used for a random variable of a probability distribution, since n, or the population, is infinite. So the variance and standard deviation must be computed differently. To get the variance for the random variable with discrete probability distribution, multiply the square of each outcome by its corresponding probability, add all the products, then subtract the square of the theoretical mean from the result. Hence, the formula for the variance of the random variable with discrete probability distribution is given by variance is equal to the summation of the product x squared times p of x minus the square of the mean. The standard deviation is obtained by getting the square root of the variance. Let us have another example. Find the variance and standard deviation of the number of members who are females in example 4.1. Again, let us have the probability distribution. So the variance is equal to the square of each outcome x times the corresponding probability minus the square of the mean. So we have 0 squared times 1 over 16 plus 1 squared times 4 over 16 plus 2 squared times 6 over 16 plus 3 squared times 4 over 16 plus 4 squared times 1 over 16 minus the square of the mean, 2 squared. Evaluating further, we will have the variance as equal to 80 over 16 minus 4, that is equal to 1. Now for the standard deviation, since it is just the square root of the variance, then the standard deviation for this data is equal to 1. Another concept that is related to the discrete probability distribution of a random variable is the expectation or expected value. It is used in various types of games of chance, in insurance, actuarial science, decision theory, and it can also be used in a regular day-to-day experiences. The expectation or expected value of a discrete random variable of a probability distribution is obtained using the following formula. E of x is equal to the summation of the product x times p of x. Hence, the expectation or the expected value uses the same formula as the mean of a discrete random variable with probability distribution. Let us have an example. Among the youth of Caloocan, like in other cities in Metro Manila, a game of chance related to basketball games is popular. They call it ending. In this game of chance, the winner is determined by correctly guessing the last digits of the final score in a basketball game. Bets ranges from 5 pesos to 20 pesos. Using the digits from 0 to 9, there are 100 possible combinations of 2 digits. The sample space is the set with combinations 00, 01 until 09, 10, 11, and the last possible combination 99. If a bet of 10 pesos wins 800 pesos, what is the expected value of the game if you bet for one combination? Let us have the solution. So our value for x, or the values that x assumes, will be the gains, and these are 790 pesos. That means the bet of 10 pesos is not included in the prize money of 800 pesos. So you actually won 790 pesos. If you lose, then you actually lost 10 pesos. So the values that x assumes are 790 and negative 10. The corresponding probabilities are 1 over 100 because you placed only one bet for a combination, so that is 1 out of 100 possible combinations. The probability of losing, therefore, is the complement of this, which is 99 over 100. In constructing the probability distribution for expected value or expectation, we follow the same requirements in the constructing of the probability distribution for random variables. That means no probability is negative. A negative value, however, is accepted in the values that x assumes. Also, the sum of the probabilities must be equal to 1. And there should be no probability that exceeds 1. Now let us solve for the expectation. That will be 790 times its corresponding probability, 1 over 100, plus negative 10 times its corresponding probability, 99 over 100. So we have 790 minus 990, that is 10 times 99 over 100. Hence, the expected value is equal to negative 200 over 100. So the expected value is negative 2 or negative 2 pesos. Two things should be noted here. First, for a win, The net gain is 790 again, since you do not get the cost of a bet, which is 10 pesos back. Second, for a loss, the gain is represented by a negative number, in this case 10 pesos or negative 10 pesos. Note that the expectation is negative 2 pesos. This does not mean that you lose 2 pesos, since you can only win 800 pesos or lose 10 pesos on a bet. What this expectation means is that the average of the losses is 2 pesos for each of the 100 bettors. Here is another way of looking at this situation. If you bet for one combination, each time there is a game over a long period of time, the average loss would be 2 pesos per bet, since theoretically on the average you would win the prize money for each 100 bets made. This time, let us have some practice exercises. For each item, you will be given 15 seconds so that you will have time to answer the problem. And then play again to check whether your answer is correct. Okay, let us have number 1. At a small public library along 10th Avenue, the number of visitors per hour during weekdays has the following distribution. Find the mean, variance, and standard deviation for the data. Go. Okay, let us show the solution. Let us go back to the probability distribution. So x is the number of visitors, that is our random variable. If x equals 5, then p of x equals 0.11. If x equals 6, 0.16. If x equals 7, 0.3. If x equals 8, 0.25. If x equals 9, 0.18. So the mean is given by 5 times 0.11 plus 6 times 0.16 plus 7 times 0.3 plus 8 times 0.25 plus 9 times 0.18. Evaluating further, we will get mean is equal to 7.23. Now let us proceed to the variance. So we'll have 5 squared, the square of each values of x times the corresponding probability. 5 squared times 0.11 plus 6 squared times 0.16 plus 7 squared times 0.3 plus 8 squared times 0.25 plus 9 squared times 0.18 minus the square of the mean, 7.23 squared. In here, we will get the variance as equal to 1.52. In solving for the mean, variance, and standard deviation, students are allowed to use their calculators. So for the standard deviation, we'll just get the square root of 1.52, and that is 1.23. Let's have question number 2. According to reports, during the school year 2014-2015, of the total school-age population, that is 12 to 15 years old, in Caloocan City, the probability that a student is enrolled outside of Caloocan or an out-of-school youth is 0.453. The probability that a student is enrolled in a private school in Caloocan is 0.089. And the probability that a student is enrolled in a public school in Caloocan is 0.458. Let x be equal to 0, 1, 2 for enrolled outside of Caloocan, enrolled in a private school in Caloocan, and enrolled in a public school. respectively, construct a probability distribution and find the mean, variance, and standard deviation for the data. Go! Time is up. Let us construct the probability distribution for this data. So we have x, the given values are 0, 1, and 2, and then the corresponding probabilities are 0.453, 0.089, and 0.458. Now to solve for the mean, we'll have the values of x times their corresponding probabilities. 0 times 0.453 plus 1 times 0.089 plus 2 times 0.458. Then evaluating, we will get the mean as equal to 1.005. The variance is equal to 0 squared times 0.453 plus 1 squared times 0.089 plus 2 squared times 0.458 minus the square of the mean, 1.005 squared. You may use your calculator and solve for the variance. You will get 0.91. That is rounding the answer to 2 decimal places. Since the standard deviation is the square root of the variance, so we get the standard deviation as the square root of 0.91, and that is 0.95, rounded off to 2 decimal places. Next, number 3. A popular fast food chain had its first drive-thru service in the city. The number of customers arriving during a 15-minute cycle is distributed as shown. Find the mean, variance, and standard deviation for the data. Go! Time is up. Let us show the answers. So in our probability distribution, the values that x assumes are 0, 1, 2, 3, and 4. These are the number of customers, and their corresponding probabilities are 3 over 25 for no customer, 4 over 25 for 1 customer, 8 over 25 for 2 customers, 7 over 25 for 3 customers, 3 over 25 for 4 customers. Of course, the probability distribution satisfies the requirements for constructing the probability distribution for a discrete random variable. Now let us solve for the mean. That will be 0 times 3 over 25 plus 1 times 4 over 25 plus 2 times 8 over 25 plus 3 times 7 over 25 plus 4 times 3 over 25. Evaluating the mean further, we will get 53 over 25. Then for the variance, we will have 0 squared times 3 over 25 plus 1 squared times 4 over 25 plus 2 squared times 8 over 25 plus 3 squared times 7 over 25 plus 4 squared times 3 over 25 minus the square of the mean, 53 over 25 squared. And evaluating that, we will get the variance as 866 over 625. So the standard deviation is the square root of this. That will be the square root of 866 over 25. And in decimal form, that is 1.18. Next, number 4. In example 4.3, if a bet costs 20 pesos and wins 1,600 pesos, find the expected value when a player plays 2 bets. So this is about the game of chance, the ending. You have 15 seconds. Go. Time is up. Let us show the answer. So for the values that X assumes are the gains, which are 1,560 because a player placed 2 bets and a bet cost 20 pesos times 2, that's 40. So we do not get that when winning. You only actually get 1,560. Next is negative 40, again because the player placed 2 bets. The corresponding probabilities, 2 over 100 because there will be 2 chances of winning out of 100 bets. And the probability of not winning is 98 over 100. So the expected value will be 1,560 times 2 over 100 plus negative 40 times 98 over 100. So that will be 3,120 over 100 minus 3,920 over 100, and that is negative 8 pesos. Next, number 5. A game initiator placed 10 20 peso bills, 5 50 peso bills, 3 100 peso bills, and 2 500 peso bills in a box. For a bet of 100 pesos, a player is to pick a bill from the box. Whatever bill is picked, that will be the player's prize. Find the expected value for the game. Go. Time is up. Let us show the solution. So in constructing the probability distribution, the values for the gains will be 400 if ever the player picks a 500 peso bill, 0 if ever a player picks 100 peso bill, negative 50 if the player picks 50 peso bill, and negative 80 if the player picks 20 peso bill. The corresponding probabilities will be 2 over 20 for 400 pesos because there are 2 500 peso bills out of the total 20 bills. 3 over 20 for 0 because there are 3 100 peso bills out of the possible 20 bills in the box. 5 over 20 for negative 50, and 10 over 20 for negative 80. Do not forget to check whether your probability distribution satisfies the requirements. Let us add all the probabilities. That will be 2 plus 3, 5, plus 5, 10, plus 10, 20 over 20. That is equal to 1. No negative probability, no probability exceeds 1, then the probability distribution is correct. Next, let us solve for the expectation. That will be 400 times 2 over 20 plus 0 times 3 over 20 plus negative 50 times 5 over 20 plus negative 80 times 10 over 20. Evaluating this further, we will get the expectation or the expected value as negative 12.50 pesos. For exercises on this topic, copy of the exercises may be downloaded from the link given on the description of this video. That is all. Thank you for watching. Please subscribe for more math lessons.